x plus dx minus y. And from the question, y itself is square root of x. So by substitution, we have x plus dx minus what is y? Root of x. You know, this is the same thing as saying, dy is equals to x plus dx raised to power 1 over 2 indices minus x raised to power 1 over 2. Now, here we are having, if this is treated as an entity, and this is another one, and we are looking at difference of two, power of half, just like you have difference of 2 squared. Recall that a raised to power half plus b raised to power half. Now multiplying a raised to power half minus b raised to power half will give me a minus b. If we now say, or if we try to make a minus b, that is a raised to power half minus b raised to power half, the subject of the formula. So we would have a raised to power half minus b raised to power half to give me a minus b divided by a raised to power half plus b raised to power half. Now the importance is that we can say let x plus dx raised to power half be a raised to power half, and then b equals to x. So that is now going to be a raised to power half minus b raised to power half, which is going to give me this derivation. So let's come to this place and say let my a equals to x plus dx, and then definitely let my b be equals to x. And if I have x plus dx minus, that is raised to power half, minus b, which is x raised to power half, we know that the expansion is going to give me a minus b divided by a raised to power half plus b raised to power half, and that is going to be a x plus dx minus, what is b? b is x, minus x, then divided by a raised to power half from here, that is x plus dx raised to power half minus, okay, it's plus b is x raised to power half. That is the expansion of this is expected to give me this. So dy now becomes x raised to power, it becomes x, of course, this x will cancel this minus x, so it becomes dx all over x plus dx raised to power half plus x raised to power half. Now the rule now says you are finding dy dx, that is divide all through by dx, and that is going to be dy over dx, and this statement is the same thing as multiplying all through, multiply all through by 1 over dx, and that's going to be dx all over x plus dx raised to power half plus x raised to power half, then multiply by 1 over dx, and this will cancel this. Now dy, okay, we say dy over dx from here is going to be 1 all over x plus dx raised to power half plus x raised to power half. Now the limits now of dy over dx as dx is tending to 0. Now remember that when you are taking the limits as dx is tending to 0 from the rule which many who claim to be mathematicians do not know. This capital dy dx, which is the change, will now turn to this dy dx. So what it means is that when you see the x, you put 0, and that is going to be 1 over x plus 0 raised to the power half plus x raised to the power half. And this is the same thing as dy over dx is equals to 1 over x raised to the power half plus x raised to the power half. And it's the same thing as dy over dx is equals to 1 over 2x raised to the power half. And mathematically speaking, from the law of indices, this is the same thing as saying dy over dx, which is going to be 1 over 2x raised to the power, basically it's supposed to be 1 over x raised to the power half. The rule of indices, then it becomes x raised to the power minus half. So when you differentiate y is equals to root x, now we are using first principle, you are going to get 1 over 2x raised to the power minus 1 over 2. Now follow us in the next class where we are going to differentiate. In the next class, we are going to find the first derivatives. In other words, the rate of change y is equals to 1 over root of x. So in the next video, we are going to see how we use first principle to actually find the derivatives of y is equals to 1 over square root of x. And this is Math 103. Thank you.